Fleet assets like locomotives, aircraft, and military weapon systems have long service lives, typically measured in decades. Technology changes massively during the typical lifetime of a fleet asset. The upshot is that a large portion of the world's fleet assets have outdated onboard technology. On this podcast, we've previously discussed cybersecurity risk of having decades-old, vulnerable electronic components responsible for the critical system operations. In this episode, we'll discuss the flip side, the opportunities to run more profitable, safer, and smarter operations by upgrading fleets with modern technology. Today, I have with me Ellie Daw. Ellie is the product lead of anomaly detection and data science at Shift5. Her focus is on aligning analysis with scalability and impact for customer data sets. She comes from a background in applied cryptography, secure protocol design, and industry research for emerging technologies, such as quantum and private computation. Rebeccah Wrady also joins us. Rebeccah is the product lead of apps and experiences at Shift5. She's focused on ensuring that customers can easily extract key insights relating to the health of their fleet and individual assets. She began her career in automotive manufacturing at Mercedes-Benz and has worked in QA, data, and product management roles at multiple startups. Rebeccah, Elliot, welcome to the show.
Thanks for having us.
Of course. I'm really looking forward to this conversation. I feel like sometimes we talk about all this doom and gloom with industrial assets and fleet assets where like these things are made in the 90s, they're totally insecure, the sky is falling. And sometimes I think it's hard to remember that there's a lot of upside and potential in looking back at these assets and potentially making them smarter while you're making them safer. So I want to kind of start out with some key insights about technological innovations that have happened over the past 30 years, because I think sometimes it's hard to believe just how much progress we can make with modern technology on some of these older assets. But when you dig into some of the technology that over the past decades we've seen come to market, it becomes way more believable. So Ellie, I wonder if maybe you could walk us through a little bit about how computer processors have changed so much in the past couple of decades.
Yeah, so I guess starting in the 90s, cutting edge processors like the IBM Power One ran at 30 megahertz on a single core and costs over $5,000 in today's dollars. But today you can buy an ESP32 for $10 that runs at 240 megahertz on two cores. And it also comes with, Bluetooth and Wi-Fi and only runs on two batteries. So it's just kind of, I think to me, like comparing the cost and just thinking about like Moore's law, like where are we going as these things continue to get cheaper and better?
What's amazing about some of the IT that we have in our daily lives, like cell phones and laptops, we recycle these things a lot. You think about every 2 years, you're getting a cell phone. Every 6 or 7 years, you've got to recycle a server. But Rebeccah, maybe you could tell us a little bit about how, for some of the customers that you've seen on the industrial side, like how long are these assets in service and how does it compare to IT systems?
We were actually talking about this with a couple of our customers just the other day, and they were telling us that in the freight rail side, they've actually seen some systems that have locomotives that have been there for 53 years plus. So it's much longer than a regular IT system.
It's amazing. And Ellie, I think I remember seeing, I don't remember whether it was a DEF CON or a Black Hat talk, but there was like a virtual walkthrough of, I think it was like a Boeing, what was it, a 747? And there were some pretty remarkable things that we found on these like aircraft that are in service. I don't know if you could maybe talk through a couple of those interesting features.
I think it's really interesting. It was a Boeing 747. Planes, like fleets of planes, are another kind of example of things that are in service for a really long time. But one of the standout things is that they still use like floppy disks for their software upgrades, which is crazy. And I think, my background kind of coming from networking a little bit, like when there's a crypto vulnerability in a protocol, it's just like, oh, we're deprecated, like install the patch, you're fine, good to go. But like on bigger systems, like Boeing 747 or like freight rail or anything like on the defense side that has to kind of have so much Q&A, and like we have to be sure these things are safe and they work the way they're intended. Like we can't just completely deprecate something. We have to be able to like provide security on the stuff that's legacy.
It's amazing. And it's not just Boeing 747s. I mean, I think, didn't you say there was something about like nuclear arsenals where we're still swapping floppy disks around?
Yeah, I think it was a 2019 article about the Air Force, like an article in 2019 announcing the news that the Air Force was moving away from doing their upgrades with floppy disks on the nuclear weapons arsenal, which is just like, it's crazy how long the lives of these things are, but also, even though, we kind of laugh like, oh, floppy disks, but I don't know, legacy systems still have to be secure. Like, we still have to be able to provide safety on these things, even things that are being deployed today that might be around for 30 more years. Like, they have to, be safe for 30 more years too.
Right. And I feel like, to some of what we're thinking about with functionality that you get out of modern technology versus functionality you get out of technology that came 30 years ago. You think about a floppy disk, I think it's like 1.4 megabytes or something that you can store on one of these things. And like you take pictures on your cell phone that are like 30 megabytes these days, right? And it's
Yeah.
kind of funny to laugh at that difference, but Rebeccah, like when you're developing applications for customers to solve problems, I mean, you'll have deployments of applications that are in the hundreds of megabytes, right? And so, I mean, how limiting do you think it is to have an update mechanism to the technology on these systems that's like such a teeny amount of information? I mean, is that a problem?
I think one of the things that we've seen just for every industry we've looked at so far is just the fact that they are all trying to figure out how to work around those limitations and figure out how to bring these new components and these new types of technologies to these older systems. And so how can they scale that up? How can they have more than 1.4 megabytes to be able to adapt and change quickly in the world that we live in?
Right. And I mean, I guess, I'm talking to two product folks. So it's always, we've always got to be thinking about what are the problems that we're solving for people. I think it's easy to squirrel about how cool these really fast processors are and all these brand new whiz bang protocols for like getting data onto and off of these assets. But like, what are some of the problems that modern fleet owners are facing that modern technology solves over older technology?
So some of the things that these larger, newer fleet systems are facing is they're wondering, what is actually happening on my fleet? The computers are not in front of the engineer. They're way in the back of the locomotive. And this isn't just in trains. This is in so many different systems. I mean, I remember working at Mercedes, we were relying on lights to flash at the right time and just praying that the system was telling us, hey, there's an issue, we need to address it. And so I think, trying to adapt, trying to change, and trying to make things a little bit easier and bring those insights to the forefront, alerting them and helping them become more proactive.
So it sounds like it's not just the operators of the assets. So like, the conductors of the train or the pilots in the aircraft. We're also talking about the people that are in charge of managing operations where these fleets are involved, right? So like, assets back in the 70s, 80s, 90s, like there weren't really good ways of getting lots of data off of these systems. And that's reflected in, when Ellie was talking about processors, you had like the Power PC, Wi-Fi wasn't invented back then. Cellular service and satellite service were like obscenely expensive. But nowadays with a $20 component, you can communicate tremendous amounts of data over pretty long distances with really low power, right? So I think it sounds like there's a big opportunity for integrating some of these modern components onto older systems that otherwise work very well, but you're upgrading them so that you're collecting more data, you're relaying that data in near real time so that you can operate fleets more efficiently. Like, what are some examples of things that, for example, a locomotive operator might want to know about their fleet that they're currently not getting out of their aging legacy assets?
So one thing that we've recently seen is that they just don't know where their locomotives are. They know it in generalities that, this one's going to be on this line at this time, but there's nothing that's telling them you are right here, right now. This is what's occurring. They're looking for the information surrounding these locomotives at a time of fault. And so they're saying, we saw this traction motor cut out, but why? What happened? What other things are there going on in my system that I can start to look for indicators that I can start to predict and start to change and make sure that I'm getting ahead of the system instead of, fighting a fire that's already occurred.
Yeah, and that brings up a really interesting point, Rebeccah, which is, there's a distinct set of problems around maintenance that is not operations. It's not situational awareness. It's, well, we have this stream of data that's coming out of all of these sensors. You've got the traction motors and the braking systems and positive train control. You've got all of these different things that are putting heartbeats onto the data buses. Ellie, like, as a data scientist, what can you pull out of that data that, say, maintenance codes and error faults aren't going to give you?
Yeah, one of the biggest things is trend lines, like just being able to kind of see the history of things. And of course, on the more advanced side, like getting to predict from there. Another thing is kind of overlaying all of these different data points. And like Rebeccah was pointing out, like what kinds of things might have kind of contributed to a fault in another part of the system, or even just bringing in like other contextual data that may not be from the train itself. And just trying to kind of bring literally everything that you could possibly like put in one place to figure out exactly what happened.
I mean, how important is more data? Like, if you're already collecting, temperature readings, and your maintainers are going around every once in a while to pull the error codes, and you're sort of running your locomotives until they break, like, how much better could things be?
I mean, I think in graphs, but like if you can kind of picture, like if we have the entire trend line and it's kind of doing this, but the like maintenance person kind of is pulling at like just only the tips of these like, mountains and valleys, then they're not going to actually see that, this certain component was spiking up and down. They're just going to be like, well, it was this value the whole time. Like, I don't see a problem. So it's kind of only part of the picture, right? And just being able to provide like visibility into the whole data set is incredibly powerful.
And it strikes me that there's like a lot of opportunity for anomaly detection, right? The more data that you have at hand, the more baselining you can do, the more you know what normal looks like. And so if you've got a really strong baseline, and you've got a kind of error bands for where the tolerances should be, for example, for how much pressure is in the engine when it's outputting at a certain level. Once you start seeing deviations from that, that's a pretty good indication that you've got like a maintenance problem, right? One of the things that's really interesting about you, Ellie, is that you have a really deep cybersecurity background as well. And what's so interesting, I think, about the OT space, the operational technology, and looking at fleet assets, is there's a very similar pattern to how you look at data when you're looking for maintenance problems and when you're looking for a cyber intrusion. And so there's, in a funny way, cybersecurity techniques in the OT space can almost deliver like additional value to customers beyond like mitigating risk. Does that sound about right?
Yeah, it's actually really fascinating, I think, to me, that some of the analysis that like has been going on for a long time on different like cybersecurity network research, topics can be applied to other places, but also like just the ability and intelligence to kind of understand how to properly train and like how to properly baseline on these data sets and sort of what methods we can use to accurately predict things is, I mean, we've seen at Shift5 how well it can actually apply to like operational intelligence, which is really cool. I don't know, it's kind of compounding all of the like knowledge that we have and that we're continuing to build and just applying it in like as many impactful ways as we can.
Yeah, it's really cool. And I mean, sometimes problems call for sophisticated statistical approaches and novel ways of aggregating data and things. But Rebeccah, I think in some of your experiences, you've seen examples where like the systems just don't talk to each other. And the way that operators are dealing with this is basically putting people in the middle. What are some of your experiences with how modernizing technology and bringing modern software engineering principles to some of these aging software and hardware systems have been able to like make people faster in their job, and in some cases eliminating menial tasks?
So one of the things that I always think back to is kind of going back to what Ellie was talking about in looking at ideal situations, you are stopping the machine. You're saying, okay, this is what this temperature is at this point. So you're only looking at the ideal situation for this machine. You really can't track and trend based on the number that somebody's writing on a spreadsheet. And you're just hoping that someone's feeling the need to drop that into an Excel spreadsheet or the database or the system that you're working in, because otherwise you've got yourself like a stack of pieces of paper where they've written like, oh, at this point, 3 days ago, it was 27 degrees and now it's 34 degrees. And I don't know what happened in between. And you're hoping that they remembered to take those measurements and to track as they were supposed to. And so I think taking the human error out of it, and allowing these people to go in and actually do meaningful work, put their hands on the machines, put their hands into the actual situation instead of having to, go around and make sure that this bolt was tightened 37 degrees and it's where it needs to go. I mean, you're just removing all of those situations and removing those opportunities for points of failure and just making the entire system smarter. I can think back and working in the manufacturing environment, and just if my windshield robot could have talked to my cockpit robot, I could have made sure that these two systems were aligning properly so that every time I knew that they were in the same area. And just thinking of what could have been would have been so helpful.
Just like driving the nail on what Rebeccah said, like it's allowing the maintenance people to shift their focus, right? Like they're still working on the same systems, but instead of having to like constantly feel like they're playing catch up, now they have visibility into the data that has always been there, and they can focus on like optimizations or whatever predictions. It doesn't matter, but like they get to kind of put their like brain power to a different set of problems, which I think is really cool.
Yeah, I think it's just so exciting, especially when you think about some of these deterministic business rules that like, okay, every time there's a maintenance code that a locomotive throws, or we see this error code or request for maintenance crossing the bus on an aircraft, within a minute, just automatically generate a ticket for it, because we know that a maintainer is going to have to do it. Because the way we're doing it right now is, there's, instead of having software encoded business rules, you have people encoded business rules, where you take one of your best maintainers and they're going to go collect error codes on some sort of schedule, you hope, and then they're going to manually type in, tickets for maintenance. I think there's just so much improvement, and it strikes me that like the differences in running operations more and maintenance more efficiently are just so massive, right?
I think one thing that kind of goes along with what you're talking about is you're actually going to maintain and retain your employee base even longer, because now they actually get to do maintenance. They get to go and do the things that they want to do, the things that they're good at. I mean, they don't want to sit in front of a computer and write down a bunch of numbers and, make sure that they put their ticket in correctly. They want to go out there and they want to do what they were hired to do.
Right. Yeah. I mean, I spent a long time in the military, and I did a lot of menial tasks, and it does not improve morale. There's also, I think, a really interesting set of users that this modernization of industrial assets has hit, which is we've seen environmental, social, and governance type employees benefit a lot from the data that's available when you're collecting all of it, right? You think about, I mean, we've had a couple of examples of California regulations where we had to try to, customers were trying to estimate pollution along certain tracks, and how much easier is it when you have a database that you can just query and aggregate the data and do kind of simple summary statistics rather than guessing, right?
Yeah, we were talking about it the other day about somebody was looking for the consumption so that they could see that and then compare it to the numbers that are coming from the EPA. And they are only able right now at this point to pull annually. And we can help them get to by hour. We can help them get to by GPS, by day. I mean, it was opening up the opportunity for so many more insights and so much more information.
Yeah, it's awesome, and I feel like it unlocks the ability to be much more eco-friendly, right? Because if you're not only for like detecting when, to Ellie's point, when there's an anomaly from the baseline of like, wow, this thing is really like spewing a lot of carbon into the atmosphere. Like maybe there's a maintenance problem when we need to go in and change the oil, or we've got to do an engine cleaning or whatever, right? I mean, there's a lot there, and I think there's a lot of opportunity in some of these civilian spaces, but even in the military, I think there's a huge opportunity. I mean, I remember one of the most important things in the military is mission readiness, right? Everybody talks about mission readiness. It's like you want to make sure that all of your equipment and your people are ready to get deployed, and they meet the standards for being able to be in service essentially. And it's really hard to collect that data right now. It's a very manual process where you've got to go around to each one of the assets, if it's a ground combat vehicle or if it's an aircraft, and you're taking a computer, you're manually plugging it into these things, and you're downloading whatever data is available, and you're kind of at the mercy of whatever the OEM is exposing to you. So it strikes me there's a lot of opportunity even in the military, where that's not even a profit-driven organization, but it still has a mission to do, and you need to have operational capability.
Yeah, I think just like the power of being able to pull up just like a dashboard and like, oh, here are the vehicles that are ready to go. Here are the ones that like need to go into maintenance. Like just having that available to you to make decisions is just game changing, I think.
Tapping into that, having to pull the information over and over again. I've heard people say, I have to pull the information and just hope that the right person brings it to the maintenance facility where we're working. Otherwise, it just gets lost in not even cyberspace, literal true space.
Physical space.
It's also like a similar thing with cyber attacks though, right? Like a lot of times when you're trying to kind of track these down, it's like, well, I hope that we have the right data collected. I hope that we are able to like pull values where we need to. I hope that, maybe the maintenance person wrote down the value on the day that I needed it, like it's hard. It's really, really hard to track these things down when there's no data.
Yeah, I mean, the data is the substrate for everything, right? It's like for operations, for maintenance, for cybersecurity. One interesting counterpoint to all of this technological innovation, though, is there's I think, a valid concern that if you're going to put a whole bunch of newfangled technology onto these systems, that you may yourself be introducing cyber vulnerabilities, right? Like, so if, for example, there's a system that is relatively closed, I mean, we can argue about how closed they are if you're plugging, Windows 95 laptops into and out of them, or you have floppy disks that are getting traded around, but all else equal, adding a device that is, for example, connected to the internet, has a 4G LTE connection, or is communicating over Wi-Fi, that has access to the data bus, which, if we've discussed at length on this show before, these things are not designed with cybersecurity, so they are in and of themselves root access to the system. How concerned should we be about companies that are introducing new technology onto these old systems?
I think this is like a really interesting thought exercise, especially with the news of SolarWind like recently. And just kind of everyone's mind is on supply chain security, right? And like, how can we make sure that we're vetting the vendors that we're putting on our platforms? I think like in some scenarios, especially like fleet kind of operational intelligence and cybersecurity, it's interesting because you have the dichotomy of like, these systems may have been designed at a time where like cybersecurity wasn't top of mind and it like wasn't really feasible for someone to perform a cyber attack, or to, I don't know, the pipe dream of having operational intelligence was not there. So it's kind of like chomping at the bit to get that. But we can't forget that like bringing in new technology to give you those things needs to be done very carefully, and like we have to follow new processes, right? Like we don't want these issues to happen again, so we'll just make sure that like threat landscapes are kind of looked at and evaluated, and make sure that like we've had red teams or like pen tests done on everything, and just really like a full top to bottom analysis of whatever you're plugging into the system, on top of like continuously checking in on this, right? Like it's not going to be a one and done.
Yeah, I totally agree. And I think, it also emphasizes like the interesting aspect of the overlap between cybersecurity analysis and operational intelligence of the same data streams gives companies opportunities to deliver value propositions to both of those user groups. And it's almost encouraging because if a company really has cybersecurity DNA and that's a lot of their background, that's a good thing because they're going to be introducing a whole bunch of new technology onto your system, right? But it also creates challenges, I think, from the user's perspective. So Rebeccah, like I know for you, having to think about different kinds of user personas is really interesting, right? You've got maintenance personnel who have a fundamentally different set of experiences and problems than operators, who are very different from, SOC analysts, who are used to SIM tools and things. So can you tell me a little bit about how you handle all of that wide range of users and maybe some intuition for, it might be the same data, but you're really solving very different problems with it?
I think something that's really cool about our solution is we have a lot of flexibility in how we display the data. So we don't just have ourselves limited to one dashboard. We've got 37 different dashboards we can have, and we can say, hey, you know what? This is going to be the dashboard that you're going to utilize. Let's say the CEO of the company, his North Star is not the same North Star, or her North Star is not the same one as the person who is out there driving the train. The person driving the train is like, I get from point A to point B and I do it securely and I do it safely. And that's what I need to do. The person who's the CEO is, how many trains did this? Which ones had issues? How do I make sure that this isn't going to happen again? How do we prevent this from occurring? And then who on my team is going to handle fixing this, making sure that this is going to work better, and making sure that we hit the North Stars and the goals for our entire company. And so what we do is we just kind of sit down and talk to people and say, hey, what keeps you up at night? What are the things that you walk in the morning and you're wondering, I wonder if X happened, or I wonder if Y happened? Because, a train engineer is going to walk in and they're going to go to the train that they're supposed to go to, and they just hope that the right person took care of the things that they needed to. But the person who's coming in from the maintenance supervisor side is like, okay, what does my team have to do today? What is going to be something that we may run into? What things have happened to other companies so we can make sure that we can arm ourselves and equip ourselves with the right information. So we're able to help each person individually because we can customize those solutions and customize each dashboard to make sure that it fits the questions they're asking that day or the North Star that they work towards each individual hour of the day.
Yeah. And I think what's so interesting about, to your point, Ellie, just collecting everything you can, is that there are really interesting ways of answering a whole wide range of questions. And when you have the data already, it's not like a huge lift to add new insights or different ways of parsing that data and looking at it. And really at the end of the day, it's all about making decisions, right? It's like, I have to make an inference here, and I need data to support that inference. So it's really exciting. Ellie, tell me a little bit about you have a pretty good finger on the pulse of how cybersecurity trends are going in these spaces. Are we headed in the right direction from a cybersecurity perspective? Are you encouraged by what you're seeing in new systems? Are you seeing other players in the ecosystem looking at legacy systems and trying to keep them safe?
I think yes to all of the above. I think a lot of people in the InfoSec community, like myself included, look at things like doom and gloom sometimes, but everything is so bad. There's so many vulnerabilities everywhere. But I do think, and I see the industry putting cybersecurity as a priority. And when new systems are being developed, they are putting together threat models and analyzing attack vectors and having penetration tests done before things are deployed, or fuzz, anything that you could put kind of into a pipeline for development. I think a lot of companies are thinking about those things and are doing those things, which is super awesome and super encouraging. I also think that there are companies looking at legacy systems and trying to do that as well. I know I don't know, it's kind of weird to think about legacy systems and why are we putting the money in to protect this? It's so old, but it's also good to keep in mind what goes into getting these things deployed in the first place, and like the responsibilities that each system has, like it's not as easy as like, okay, tomorrow we're starting with the new thing because this is too old. Like these things we were talking about it earlier, like the train that had been in service for 50 years or whatever, like it's going to continue to be in service probably. I don't know what train you're talking about, but like like we have to be able to make sure that the old things can continue to work. And I think that is on the minds of a lot of like other infosec companies, which I think is really cool because I think a lot of companies are looking at this from different perspectives and kind of applying like the different specialties maybe in cybersecurity, like applying those brains to the problem and applying like just brains from all perspectives to the same data set, which is how we're going to really like improve more quickly. Yeah. And the more insights that we get, the better we can do in the future. And the more we can like make our predictions better, like everything I think is headed the right way.
And the consequences are pretty grave if we get it wrong too. I mean, these OT systems, they move in the physical world, right? Like you look at a lot of cyber attacks on IT systems and it's like, okay, it was pretty bad. I mean, some of them approach loss of human life. I mean, I remember there was a hospital that got hit by ransomware and like couldn't schedule surgeries, for example. Like that has meaningful impacts on people's health.
I think this year we had the first like death at a hospital due to ransomware in 2020.
Yeah, it's just really, really awful. And I think when you do nefarious things to operational technology, the scale is just, you think about trains having hundreds of people in them. And what if you cause one of those things to break down in the middle of nowhere or in a tunnel and you rev the engine and, like you can just think of all these awful examples or in a, we looked at the Boeing 737 MAX 8 example of that was, as far as we know, sort of a design issue, but ultimately it's very similar to how cyber attacks work, right? Like there was an erroneous message that went across one of the avionics data buses that made the system think it was in a bad state, in a stall condition, and then it like took over for the pilot, and hundreds of people died. So I'm glad to hear that you think we're headed in the right direction there. Rebeccah, I guess from a maintenance and operational perspective, we talked a lot about how the state of the industry for a lot of these commercial verticals is pretty manual, and these legacy systems are not supporting more modern, efficient workflows. Like, what are you seeing in for example, the rail industry? Are you encouraged by, I guess, number one, the attitude that operators and maintainers and the owners of these rail systems have towards embracing technology? And then number two, are you encouraged by some of the technology that's getting offered to these operators?
I am. I think one of the biggest things is people have to learn to open their minds. And we're starting to see newer generations coming into these maintenance roles that are, they're used to the computers, they're used to the cell phones, they're used to all of this stuff. And for them, it's just not acceptable to not have that at their fingertips and not have that available to them. The first time I had a sit down conversation with a maintenance team and helped them solve a problem and then saw it on their report out the next week. And, Shift5 had helped them solve this problem. It was so great to see how excited they were and how engaged. It was a conversation. It wasn't just us coming to them and saying, hey, we're going to fix your problem. We truly helped them fix the problem. And so I think it's opening the minds, seeing that the teams really get excited about the opportunity to cut down on the menial tasks, cut down on these things that are not benefiting them or the company, and really help them, forgive me for being cheesy, but like unlock their careers because it's helping them create a really great career that's fulfilling and exciting. And there's so many people in the market of data and helping disseminate this information and get it to everybody else. And so now I think it's really up to us, the people who are providing this data, to not make it intimidating and to not make it something that's really difficult, but really to make it something that's available and something that's easy and something that's exciting. There's a ton of initiatives around data right now. And the more we can do to educate people that this is going to help them and this is something that can be really exciting for them, I think we can really help a lot of industries progress forward. We've seen a ton of innovation during the time of COVID, and I think we're just going to continue to see that as a domino effect.
Yeah, and I think one of the dynamics that's so important to realize as a tech company is, we may be experts in our niche, which is, getting onto data buses, collecting data in a really efficient way, storing it, processing it, transforming it, and then presenting it. But we're not the experts in operating these businesses, right? Locomotive railroaders are experts at railroads. We're not experts at that. Airline maintainers and pilots are experts at how to operate those things. Military commanders are experts at using their vehicles to accomplish missions, right? And so, one of the most important things about product as a community of practice is realizing that, right, and interacting with users in a way where you're saying, hey, tell me your problems, educate me about how you do your job. You're the expert here, but I want to solve some of your most painful problems with technology. Can you tell me a little bit about what that process usually looks like, and how long does it take for you to, for example, take a problem and then converge on a solution for the user?
So if we are already on the system and we already have all the data that has been parsed and everything is available to us, we can iterate incredibly quickly. We can turn out dashboards in under an hour. It's amazing. And we can hop on a call and say, what are those questions you're trying to answer? What are the things that are keeping you up at night? What is the information that you need at your fingertips? We can get that to them incredibly quickly. And so by us just sitting down and having conversations and listening and saying, what happened today? What was in your email inbox when you came in this morning? What were the things that, were major fires? What is your boss telling you that we need to solve this problem yesterday? What's going on? Like, what caused that epic failure that you just can't get out of your brain? And so you're like, how do I not have this problem again? Because with the data that we're providing, we can help them not have those problems again. We can
Right.
make it so that they're able to know that, going along with the trend data, like when your pressure drops really low, you're going to have issues, or when your pressure gets really high, it means your system's backed up. We can help you prevent all of this stuff.
And I think it also underlines that technology companies need to develop relationships, like enduring, indefinite relationships with their customers, right? Like, Ellie, have you seen, even in the cybersecurity industry, a trend away from, one-off products where you just throw it over the fence, install it at the customer site, and kind of dust your hands off and move on towards this software as a service kind of model? And where have you seen that in the cybersecurity industry?
Yeah, that's a good question. I think the security industry, like, I don't know, if you think about the history of security, that it's kind of, you always think like the stereotype of the person in a basement, and like, you don't think about kind of modern, like software as a service or like relational kind of business. But it has been turning that way in the last like handful of years, which I think is really cool. And people are kind of realizing that like it doesn't have to be scary, it's kind of insights. It's a tool to help you run your business and to help you like protect yourself and your customers and the things that you and your customers care about, which is awesome. As far as like places that I see that the most, like I guess when I think about like one-off solutions, I think about kind of maybe like consulting projects or something that's like, okay, I'm just going to solve this, and then it's like handoff. But I think even in the consulting world, it's more like, instead of kind of bundling something together and passing it off, it's like, I'm going to bring together all the tools that I think will give you kind of the best shot at having the intelligence that you need. And then kind of continuing along that with like a software license, and just like, kind of equipping that team to continue along their route. I guess I just think about like any internet security kind of dashboards, and like just helping analysts to go and dig into some of the data that's coming in. which I think was like, I don't know, it seems like a similar problem to what Shift5 is solving, right? It just happened a handful of years ago where like a cyber analyst would kind of like not have that much data to help them. They just have to like dig around until something seemed relevant. But companies are putting that intelligence together for analysts to help equip them and like help them do the forensic analysis that they need. So yeah, I think even like red teaming and pen tests is like turning into as a service, right? People are getting these regularly, which is super awesome. Like I've seen like threat models as a service. I mean, I guess I come from like a cryptography world, but like not necessarily, it's not crypto as a service because that's like a little bit different, but just having some kind of like expertise in that world as a service, or like kind of enabling companies to like upgrade their software. I don't know, everything just seems like it's kind of continuously happening so that companies can continue along their path and do so safely.
Right. Yeah. I mean, I think it puts the vendor on the hook to like delight the customer, because if you don't, you're not going to get renewed. Right. It reduces a lot of the risk for customers, because they're not like, oh boy, this is going to be a big purchase that I've got to amortize over a 5-year period. Like, I'm going to start this. It's a relatively like low lift at the beginning. And if it doesn't work out, like, sure, there's some wasted time and energy there, but ultimately like the outlay wasn't huge, you know?
I think it's still changing. Like, I don't think we're quite there yet, but I think a lot of the time the cybersecurity like software solutions or whatever feels like something that you have to do. But companies are kind of getting into the mindset of like, no, I want to delight them. Like you said, Josh, like I want this to feel like something that actually helps them, and like they can actually feel the benefit instead of it feeling like a burden.
Yeah, totally. And Rebeccah, maybe, I mean, you're in the trenches on a lot of this kind of customer engagement. What does a typical customer engagement look like, if there is such a thing?
So I always look at the answer, it depends. So one of the things that we've tried to do is figure out a way to almost insert ourselves alongside the team so that we are helping them and guiding them. We're working towards a training program to help people understand what is available to them so that they know, and they can come to us and say, hey, I've got this dashboard, but if I could have this one little additional thing on there, I could really, save 10 hours a week or save this amount of time. And so it's just a consistent almost dance of how do we continually have a conversation and open up those lines so that we're optimizing, we're making things better. A lot of things kind of going along with what you both were talking about with delighting the customer. So many times we have conversations and people are, they're talking about legacy systems. We're like, man, they work so slow. The things aren't changing. And then we walk in and we're like, here's your new dashboard. I just made it 30 minutes ago. And their minds are blown and they're just so excited.
Yeah. It's amazing what you can do in some places with like just the right insight and a little bit of like elbow grease on the software engineering side. You can just solve amazing problems. And the other thing that's kind of neat about having a long-standing relationship with customers is that products evolve, right? So like what a product looks like today may look very different than what it looks like 2 years from now. And if you have a continuing relationship, you just sort of benefit from the evolution of that product that gets rolled out month over month. So Ellie, I know you had a pretty interesting factoid about floppy disks and cybersecurity that has some pretty interesting history.
Yeah, I think it's pretty funny and kind of relevant, so you'll have to hang with me for just a second. But in 1989, there were 20,000 floppy disks sent via just like snail mail, mostly to kind of hospital or like medical research type institutions that claimed to be like AIDS education, which kind of side note, but harkens back to like the scammers taking advantage of COVID stuff in 2020. But so these floppy disks actually had ransomware on them and used like just asymmetric crypto to like encrypt whatever system it was inserted into, and then asked for a ransom, like, pay me and I will give you the key to unlock your like locked data, which had a huge impact. There were a bunch of like research institutions that would just like deleted. I think one said that they deleted like 10 years of data or something. I don't know if they had like paid the ransom or not, but so it had this huge impact. They wound up like apprehending the guy who did it. His name was Dr. Pop. So it's like the Dr. Pop ransomware. And he, like, they don't really know why he did it. I think there is speculation that he like was rejected for a job he had applied to at the World Health Organization. But he didn't, like, the judge said he wasn't fit to stand trial because he had been like acting really weird, and he just like went on to like run a butterfly pavilion in upstate New York. But I think it's really funny. I was thinking about like floppy disks that we saw in the Boeing 747, and it's like relevant to cybersecurity, I think, because at that time that wasn't even a threat vector or like an attack vector that they were thinking about, right? And it, like, no one had seen that before. This was the first known ransomware, you know, that we can kind of track back. But that kind of started the whole ball rolling of like, oh, maybe we need to think about kind of different things that might be used in malicious ways. And I think it's easy to forget that even today, like as kind of modern and you know, advanced as a lot of our systems are, like, how can we look at things in a different way and just make sure that there aren't like weird things that are going to be used in the wrong ways that will catch us off guard? Which I think like a piece of that puzzle is kind of visibility into your data, and like is being able to see your system and just understand what's there. That's obviously not like cybersecurity is like a multifaceted thing, but I just thought that was like a fun story and like a good example of kind of an unseen like attack vector that was taken advantage of.
Yeah, totally. It's just like reason number 7,000 that you need to collect all this data on these systems. And like, I think it's so exciting to have people from different backgrounds who have cybersecurity backgrounds, who have manufacturing backgrounds that are joining forces on a common problem. And so I've really enjoyed in this show being able to talk a little bit about the operational intelligence opportunities on some of these fleet assets, and then reflect on what the cybersecurity ramifications are. So we'll definitely have you back on the show to talk about some of these things. I really appreciate you coming on to share your wisdom, Ellie and Rebeccah. And I look forward to having you on again.
Thanks for having us. Super fun.
Thank you for listening to this episode of Planes, Trains, and Tanks. If you enjoyed this episode, please consider leaving us a review. To learn more about Shift5 and our products, visit our website at shift5.io or follow us on LinkedIn and Twitter.